Right. It's my pleasure to introduce our next speaker, who is Nancy Love from the School of Engineering. And she says that she doesn't have a single favorite anything, but she does like salads and names among her favorites fattoush, salad lyonnaise, Michigan cherry salad with blue cheese, any of the above. And she's going to talk to us today about pea cycling for sustainable and equitable nutrient food systems.
Thank you very much. I'm really pleased to be here. So I think my role today will be to help you understand what this term pea cycling means. And what I'm going to do is I'm going to talk about the what, the why, and the how. So here we go. What is pea cycling? So I'm going to start on the right-hand side of this slide, which is how we handle our human waste now and our household waste. We mix everything together, the urine and the feces. We apply flush water. There's gray water associated with other applications in our home. It all comes down into one pipe that goes into a collection system, into a centralized treatment system in our community, processes everything, and then puts it back out into the environment as either effluent or biosolids. The nutrients for that are ending up back in the environment in a reactive form, the majority of those nutrients, and in a very diluted form. Pea cycling recognizes that we can capture those nutrients and utilize that circular economy of putting it back into productive use. And so what I'm showing you on top is either a waterless urinal or a source separating toilet that separates the yellow water and the black water, takes it into a processing facility, either in the same building or in a centralized collection facility, and then turns it into potentially a fertilizer or some useful product that can be used for food production, which then we eat and recreate the urine that has the nutrients in it. So next, why pea cycling? The conventional method of moving nutrients through communities is very linear, as I just explained, and it is very inefficient. So statistically, about 50 to 70% of the nitrogen and phosphorus that enter our communities in the form of food, which is the majority where the nitrogen and phosphorus enters our communities, leaves via the environment in a reactive form, either going through the solid waste process or through water processing back in as biosolids or as an effluent into a river. If we think about where fertilizer comes from, it's nitrogen fixation. I'm showing you the amount of energy per gram of nitrogen that's invested to capture nitrogen gas from the air and turn it into nitrogen fertilizer. Phosphorus is mined, and the mining process of phosphorus mining is pretty environmentally rough, I'll just say, and it also has an energy associated per gram of phosphorus. And then if we bring it through food and then this linear process into a treatment plant, the treatment plant is investing somewhere between 45 and 110 kilojoules per gram of nitrogen and another 45 kilojoules per gram of phosphorus, just to process that very diluted nutrient into a form to put back into the environment that we think is perhaps less harmful, but nevertheless, it's very wasteful and it is not sustainable. And so we're talking about trying to circularize this, capture the nitrogen and phosphorus where it is most concentrated. And it is most concentrated in our pea, which is why we want a pea cycle. And by doing that, we like to think of achieving resource efficiency in our communities by capturing that material. Now, the next question is, oh my God, now how do you do this? I showed you one of the toilets that we have on North Campus. I'll close with another picture and some comments on that. But there are a lot of technologies and quite a bit of research going on around the world associated with different ways of processing, whether you're capturing it and processing it in the same building where people provided the donation of urine, or if it's going to be a centralized processing where you collect it and kind of like our garbage where they come pick it up once a week, somebody pumps out our urine, or it goes through some kind of centralized pipeline into a centralized processing facility. When you do that, you have to do things by concentrating it even further, dealing with any kind of contaminants like pharmaceuticals, dealing with odors. And all that type of research I can talk to you more about when we have more time, but there's quite a bit of active research ongoing in this space. We're also doing a lot of work on this campus around looking at systems analysis associated with this, perception research, and how we help people recognize what this is and what the benefits are from a sustainability standpoint, and then using risk analysis and risk communication to talk about it. So I'm going to close by saying U of M is #1 at #1. And I say that because we have the first source separating toilet on a university in the United States. There's one in Switzerland too. So, and then there are a few others are growing around the world. And then we process it in the basement. This is not a composting toilet like in the data building on Central Campus, where you mix the black water and the yellow water. We separate the black water out, send it to the sewer. We collect the yellow water, process it downstairs, produce a fertilizer. And these are our partners along the bottom. Thank you very much.